So today we want to look at something different altogether. All this while we've been looking at sets. But today we want to look at another topic, which is polynomials. Now, polynomials are mathematical expressions with ascending or descending powers of variables which do not include negative powers. Now, for instance, if we have x plus 2, this is an example of polynomial, because this is a variable x, while this 2 standing alone is what we call constant, because a polynomial is made up of variables, coefficients, and then constants. But from this first example here, x here is the variable, while 2 is the constant. And this can be written, this can also be written as x raised to the power 1 plus 2x raised to the power 0. Now, if you look at the variables, like we said, it might have ascending or descending powers of variables. If you look at the variables, this one has power of 1, while this one has power of what? 0. And of course, anything raised to the power 0 is equal to 1. Now, let's look at another example. This one says 3x raised to the power 2 plus 4x then minus 8. This is another example of polynomials. Now, this is a variable, x. This also is a variable, this x here. Now, this 3 and 4, they are what we call the coefficients. And then 8 is what we call the constant. Now, this can be written also as 3x raised to the power 2 plus 4x raised to the power 1, then minus 8x raised to the power 0. If you look at the variables, they have descending powers. This one is raised to the power of 2, this one is raised to the power of 1, or this one is raised to the power of 0. Anything raised to the power of 0 is 1. That's why it is 8. So another example can also be x raised to the power 3 minus 5x raised to the power 2 plus x, then minus 6. This also is another example of polynomials. If we were to write this in this way, this is x raised to the power 3 minus 5x raised to the power 2 plus x raised to the power 1, then minus 6x raised to the power 0. But we express it in this way. We notice also that the variables have descending powers. This one is raised to the power of 3, this one is raised to the power of 2, this one is raised to the power of 1, while the one here is raised to the power of 0, which of course is 1. So these are examples of polynomials. But then, there are some expressions that we might say they are polynomials, while they are not polynomials. An example of those expressions that are not polynomials. Now, expressions that are not polynomial. The first one is something like x plus 2 plus 5 over x. And this can be written as x plus 2 x raised to the power 0, of course, then plus 5x raised to the power minus 1. This expression is not a polynomial. You know why? It says which do not include negative powers. But if you look at the last one has to the power of minus 1. That's why this expression is not a polynomial. Another example is we have something like log 2x plus 3. This expression also is not a polynomial. Reason, it has logarithm. Another one is we have something like square root of x cubed plus 2x squared, then plus 5x. This expression also is not a polynomial. Why? It has square root sign. And then the very last one is when we have something like 2 raised to the power x squared plus 4 or 4x. This one also is not a polynomial. Why? Because it is the power of 2. So you should watch out for what you call a polynomial, but in the real sense, they are not polynomials. Now let's look at arithmetic of polynomials. Now we have addition and subtraction. We have addition and subtraction of polynomials as one of the arithmetics of polynomial. And we also have multiplication of polynomials. Multiplication of polynomials. We also have division. We also have division of polynomials. Then we have the fourth one is factor and remainder theory. Factor and remainder theory. Remainder theory. This is another arithmetic of polynomial. Then the very last one, which is factorization. Factorization and the root of equation. Root of equation. So these are the arithmetics of polynomials. So in our next class, we'll start with addition and subtraction of polynomials. After that, we enter into multiplication, then division, and then factor and remainder theorem. And then we enter factorization and the root of equation. So thank you for watching. God bless you.